Well, general chemistry student's going to help you solve this challenging OWL problem. I always think it's easier, but it's pretty hard. Calculate the volume of sodium hydroxide, strong base, that must be added to the strong acid to give a solution to pH 2.05. The challenge in this is that there's a variable volume. And so how do we get started though? Well, how many moles of hydronium ion or hydrochloric acid? So remember, hydrochloric acid, strong acid, all you have to do is think of it as the hydronium ion. Get my little mouse going here, okay? So I can calculate the moles that I have by multiplying the two together. The volume times the concentration. Now remember, the volume has to be in liters, okay? Multiply molarity times volume equals moles. Let's me how many moles that I have to start off with. I recognize, well, how much base do I need to add? Now, I'm not going to react with all of those moles. I'm going to react with some of them. Well, how much? Well, the concentration of the base times the volume, but they didn't give it to me, will tell me how many moles of sodium hydroxide that I need. Well, and I remember they're going to react 100%, not 100% of what's there, but whatever sodium hydroxide when it's going to react, I don't have to worry about an ice table or anything. So the way that I thought through this one is to set up a BRF table, and I have this many moles to start off with, and then I have this many moles of hydroxide to start off with. Well, I don't know what V is for volume, so I have to keep that going through. But the hydroxide will be the limiting reactant. So I'm going to react all of those moles and make some water out of that. And when I get done, for the final amount of hydronium ion I'll have is 0.1 minus how much reacted. Well, how much is left over when I react? Well, that's what the pH at the end is for. And so if I take the overall concentration here, or the moles, so this is the moles that I have left over, I can figure out the concentration that I have at final by dividing by the total volume. See, that's changed now from the original. So it's going to be a ½ liter plus V, where V is the volume of sodium hydroxide that I added in. All right. So now to figure out the final concentration of the hydronium ion, I take the moles from here divided by the total volume from here. What's my final concentration? That's what the pH is for. So I take 10 to the minus pH in this particular problem. So pH is at 2.05. And I can figure out that the final concentration is 0.0089. Since I know my final concentration and I know a way to set up to figure it out here, I can create an equation with one unknown. So there was the moles of the final hydronium ion, and then the 0.5 plus V is the total volume at the end. So now I have just one variable. Yeah, it's in a couple places there in the numerator and denominator, but I can solve for it now. And I would multiply both sides by 0.5 plus V, and then distribute that concentration over. And so there, I distribute it. And then I can isolate the variables. So I put the constants on one side and the variable on the right-hand side. And then I can solve for V, and it's 3.999 liters. And so that's my answer. This is asking for the volume because V was the volume of sodium hydroxide. So I had to add quite a bit in there to change the concentration. So watch this video a couple times, see if it helps. I'll post the slide as well. And there's other ways to solve this, but the key was to create a variable for the volume of sodium hydroxide. Okay, I hope that helps you guys. We'll talk to you later.